Welcome students, we come back again with a new video that can give you enough knowledge. So start again. So today we discuss with the first chapter of the class 11. Okay. In this video we discuss the following topics. First of all, which chapter? Unit and measurement. In this video we can discuss that is what is unit, what is different type of units, and also what is the dimension and time uses of the different type of dimension. By knowing this, you can build your knowledge. Okay, so let's start without wasting your time. So take out your pen and copies. Let's start off with this. Class 11 students, now it is your first chapter, unit and measurement. So your syllabus is completely different than that of the class 10 and class 11, that you know already. So first chapter, that is chapter 1, that is the unit and measurement. The preliminary part of this you also know in class 10 and class 9 standard also. Okay, so let's start without wasting your time. So take out your pen and copy and write everything. This is very much interesting video and it is very much important for you also. So first chapters, units and measurement. But system is very much important. Okay, so let's see the part of this unit system. So first things, that is the physical quantity. What is physical quantity? Those quantity which describes the laws of physics are called the physical quantity. Different type of laws are present for physics. Okay, the quantities which can describe the laws of physics. If solid substance has some properties, a liquid system has some properties. So if particles is moving in the forward directions, it has some properties also, has some laws also. This can be described in the physical quantity. So classification of the physical quantity. All these physical quantities can be classified into the following two categories. The first one, the physical quantity is classified into the fundamental quantities or the base quantities. This one. So just I say that this is the quantities. Okay. So we just write this one, can be written in the form. So fundamental quantities and the base quantities. And the next one, that is the derived quantities. So the fundamental quantities. So first one, that is the length. What is length? So generally, if I want to measure the length of a substance is just less like that. Length always is measured in SI system, that is in meter. These are the fundamental quantities. Length, mass, time, temperature, electric current, amount of substance, luminous intensity. These are the 7 fundamental quantities. First of all, length. If I want to measure some length of a body or a substances, so generally according to the SI system or MK system we follow this. This is the meter. Another one, that is the we also measure with the centimeter also for the smaller substance. This CGS and SI system, why does use these two system only? Because we can convert from a CGS to SI very easily by changing the decimal places only. Okay. So now we move to the second point, that is the mass. What is mass? So consider the mass at a particular substance has some fixed quantity. So it has some mass. Quantities can be specified as the mass of this. Okay, and it can be measured for the larger mass, that is the kilograms, and for the smaller mass, this is measured with the gram. And the next one, that is the time. So what is the time? That is time measured in the seconds. It is basically for the CGS and SI unit both. And next of all, that is the temperature. Temperature, it is measured in the Kelvin for the SI system. And CGS and system, that centigrade and Fahrenheit you also know. So electric current is measured in ampere, capital A. Amount of substance is measured in mole. Okay, amount of substance, mole, is very much essential. And the next one, that is the luminous, that is the light intensity. A ray of light is coming, has some intensity, has some light. This one is denoted as the light intensity. So next we say that there is the temperature, electric current, amount of substance. After that, the luminous intensity. This one. Okay. So luminous intensity, it is very much important in this part, and it is denoted with the ESI unit, that is the candela. You just remember this one. So next, what is derived unit? Derived unit means, that is the first one. Just we mention over there, that is the area. What is area? Area, it is symbolized with A. That is in your previous classes you also described. That is, A is the total area of a substance. Consider you just take a rectangular plate. Okay, so like rectangular plate only, what is the formula in this case? Length and the breadth. So when we multiply, so if I consider this is the square plate, so both sides are same, so length into length, okay. If I multiply for the rectangle, so length into breadth and so on. So that's why length into breadth, this one measure with the area. So length into length can be measured in SI system, that is meter. So we just write that is meter into meter. The meter multiplied with m. So that means meter square. Okay. So just in this way we can calculate this part, that is the meter square is the part, that is the SI unit in this case. Okay. So next one we just say that is the volume. What is volume? Volume means, consider you have a cube. Cube has some specific value, that is the length. It has some length, it has some breadth and has some height also. So length, breadth, height, three parts is present. First of all length, second of all breadth, and third of all height. So these three parts is also present in this case. So we just measure with it. If length is measured with the meter, breadth is also measured with the meter, and height is also measured with the meter. So that is length into breadth into height, that is m into m into m. So what is the value in this case? That is equals to m cube. Okay. So we just write this one, that is the m cube is the SI units of the volume. Okay. Now come to the point, that is the density. Now a question arises in myself, it is derived quantity. Why this is? Because just check it out, area. It is depend upon the two fundamental quantities. Two fundamental quantities. This one, this is the first is the length, second is the length. Length, both are length is meter. Meter is the physical quantity. Okay. So this one, so length into length, meter into meter, meter square. So that means it is derived from the physical quantity. So that's why it is called the derived units. Okay. So say again next one, that is the density. Density equals to mass by length into length into length. That is mass by volume. So m by v. So mass, it is measured with the SI unit, that is the kilograms. Just check it out. This one, and it is measured with the mass, that is kg, and length into length into length, that is the volume. Volume SI unit, this one is meter cube. So this one, so kg pi meter cube. By using this we can find out the volume in this case. Okay. After that, that is the velocity. Velocity equals to displacement by time. So if I write displacement of a body can be measured with the length, same thing, that is SI unit, it is meter. So meter per second, that is meter second to the power -1, it is denoted with that is the velocity. Okay. So after that, the accelerations equals to velocity by time. So meter per second, this one meter second to the power -2. Clear? So by using this we can calculate all the parts, that is the accelerations SI unit, this is meter per second square. That is velocity by time, velocity is meter per second, so meter per second by second, so this one is denoted with that is meter per second square, that is meter per second to the power -2. And what is the formula in this case? That is velocity by time. Okay, so if I divided the velocity with time, we can easily find out the acceleration. Okay, so by using the formula, only you just remember the formula. By using the formula, you can easily find out the other quantity also, that is the SI unit in this case. Okay. The next one, that is the dimensional formula. What is dimensional formula? So another part, this is dimension. You know little bit about it. So we just describe elaborately in this video. That is the first one, that is the dimensional formula in this case. The first, that is the area. Okay. If I want to find out the dimensional formula, that is area. So area equals to length into breadth. So length into breadth means that is L into L, that is L square. So L square too can be written in as a power. So that is L square. Obviously when you write the dimension, write in the third bracket also. So next one, that is the velocity. Velocity, it is written in the form that is equals to displacement by time. That is displacement, that is L, and displacement by time. L can be measured. L can be treated as a dimensional of some distance. So L and T is the time. So L by T, that is L T to the power -1. And after that, the force, that is mass into acceleration, that is mL T to the power -2. Because mass is m and acceleration is L T to the power -2. L T to the power -2. Why this is? Because that is acceleration is equals to velocity by time. What is velocity? Velocity is L T to the power -1. Okay. So L T to the power -1 by T. So that is L T to the power -2. So acceleration is L t to the power minus 2. Okay, that is a acceleration is L t to the power minus 2, this one. So when we write the L t to the power minus 2, so we just measure in this case, that is the acceleration. So mass into acceleration, same L t to the minus 2. This is the dimensions of the force. After that, the work done. What is work done? Work done equals to force into displacement. Force is m L t to the power minus 2 and displacement is L. So m L square, m into L, that is m L square, the last one. So this part can be omitted. That is m L square t to the power minus 2. That is L into L, that is L square, and t to the power minus 2. So in this way, you just measure the dimension of these following quantities. Okay. So after getting the formula, this is very much important. Now we want to describe the different part, that is the why we use dimensions, different uses of dimensions. Dimensions used for various purposes. That is to measure, if I want to find out that is the relations is true or not. So we also use dimension. After that, we also use dimensions for the different cases, that is certain conditions we know that. So from these conditions, we just find out the for real formula of a particular quantity. That is the for simple pendulum or others also. Okay, and also dimension used to convert one unit system to another. That is from CGS to SI or other unit system. So now we describe one after another. That is what we can convert from one unit system to another by using the dimension formula. Okay, so let's see. So next part we come again. That is the dimension, principle of dimensional homogeneity. So physical and derived unit differentiate with the dimensions, that is mass, length, and whatever, that is ml and time t. So now first part, that is the principle of dimensional homogeneity. What is the principle of dimensional homogeneity? The dimensions of the left hand side of a valid equations must be equal to the dimension of the right hand side. This is the principle of homogeneity. Okay, now question arises, that is what is the meaning of that? Consider the s equals to ut plus half at square. Dimensional homogeneity is represent that the dimension of the left hand side. What is the left hand side? This one. Okay, dimension of the left hand side, and this one is the dimension of the right hand side. If both the dimension, left hand side and the right hand side, both is equal, then we can say that this is follow the principle of homogeneity and this is the correct. Okay, that means left hand side this one LHS and this one is the right hand side. So RHS and the LHS, if both this equal, that is LHS equals to RHS, then according to the homogeneity we can say that this equation is valid. Okay, so this one is the principle of homogeneity, that is left hand side is valid equations must be equal to the dimension of the RHS. So equations, this is mechanical equations or any other equations, it is valid or not, what we can know? That is we know from either use of this dimension, that is the principle of homogeneity. Okay, so let's discuss about that. That is the verifications of these equations. Just check it out. Left hand side. Okay, left hand side LHS. Left hand side, what is S? S is the displacement of a body. So displacement, it is specified with the L, this one. Okay, obviously written in the third bracket. So after that, right hand side, we come to the point, that is the right hand side. Right hand side, the first one, that is UT. So what is U? That is obviously, that is the initial velocity of a particle. So initial velocity, so its dimension is obviously L t to the power minus 1. So this one, and t, this is the time. So we just write this one is capital T. So what is the value in this case? That is L t to the power minus 1 into t, that is simple L. So right hand side first part, okay, that is ut, that is equals to obviously this is L. And for the second part is half at square. Now half, this one is dimension less quantity. It has no dimension, only 80 square is present. What is A? A is the acceleration. Okay, so A is the acceleration. So what is the dimension? That is L t to the power minus 2. Because acceleration is equals to velocity by time. Okay, already discussed. That is multiplied with the t square. So this one is t square. Okay, so L t to the minus 2 into t square, that is also equals to L. Just check it out. Left hand side is L right hand side in both this part, this one is also L, this one is also L. So we can say that RHS equals to LHS. So left hand side equals to right hand side. So when left hand side equals to right hand side, it can follow the principle of homogeneity. That means this equation is valid. Okay. So in this way, any physical quantity, any physical equations, we can measure the corrections of this equation. This equation is valid or not, we can easily find out by using the dimension. Okay. So now we move to the next part, that is what we can convert from one unit system to another system. That means from the SI system to CGS system, or CGS system to SI system, or any other systems. Okay, it is a number of numerical cases it will appear from this part. Next one, that is the conversions of physical quantity from one unit system to another. Okay, so we write down details to save the time. So what way we can convert some physical quantity? Convert some physical quantity, consider the one physical quantity, this is the work done. Work done equals to force into displacement. So force into displacement, force multiplied with the displacement. So if I consider the SI unit of the force is joule and the CGS unit is arc. So we can convert from joule to arc by using the dimension. Dimension is one process, so we can conversions occur. So consider first one, the dimension of the work in SI system is W1. So we repeat once again, that is SI unit of work is joule and CGS unit of work is arc. We can convert the joule to arc. That is joule, it is given, the value of joule is given, we can convert into the arc. Okay. So dimension of work in SI system, if I consider, what is the dimension? Work done equals to W equals to total day, that is force into displacement. What is force? That is M L T to the power minus 2. This is force and it is multiplied with the displacement. Okay. So that is M L square T to the power minus 2, this one. So this one represent force and this one represent the displacement. Okay. So by multiplying this, so we get the value, that is m L square T to the power minus 2. This represent the work done. So for the first case, that is the SI system, we just write this one is W1. So W1 means M1 L1 to LL1 square and T to the power T1 to the power minus 2. For the CGS system, it is written with the form that is W2, that is M2 L2 power of 2 and T2 power of minus 2. Okay. Now we consider this one first, W1 in case of M1. M1, this is the SI system, that is the mass. Mass means it is represented in SI system, that is equals to kg. Same thing, L1 it is in measure in the meter and T1 it is measured in second. Same thing, M2 in gram, L2 in centimeter and T2 in second. So by using these relations we can convert this. Okay. So now we write N1 W1 equals to N2 W2. We can convert N1 times N1 quantities of W1. Okay. Into N2 times of the W2. So N1 into W1. W1 equals to this one, M1 L1 to 80 to the minus 2, same thing right in the both side. So N2 equals to, so right, that is N1, M1 by M2, L1 by L2, T1 by T2 and write the power also. Now this conversion occur in this case. Here N1 given. What is N1? For the SI system here given, that is joule. So N1 equals to 1 joule. It is represented over there. Okay. So that is right, N1 equals to 1. M1 equals to, M1 measure in the form of kg. So it is converted into the gram. So 1 kg equals to 1000 gram. So we just write here that is equals to 1000. That is 1000 into M2. Okay, because M2 it is written in the gram. So 1000 M2 by M2, same thing. L1 by L2. L2 it is written in the centimeter and L1 is written in the meter. So L1 meter, so that is equals to 100 into L2 because meter converted into the centimeter. So 100 into L2 by L2 power of 2. Same thing, T2 and T1 both are same. So we just write T2 by T2. So M2 cancel out, L2 cancel out, T2 cancel out. So here 1, this one and here 10 to the power 3. Here 10 to the power 2 and this one is also. So this is square in this case. Okay. So 10 to the power 2 square. So 10, that is 10 to the power 4. So 10 to the power 3 into 10 to the power 4, that is 10 to the power 7. So that means in this way we can convert 1 joule into 10 to the power 7 arc. Okay. So by using, so in this video we discuss all these parts. The first one, that is the unit systems, different type of unit systems. That is after that is the dimension. Okay, and different uses of dimension. Okay, so just practice. You need a practice of this. Okay, so write in your copy very much carefully and solve different type of problems related to that. The conversions from one unit system to another for the different physical quantities. We discussed with the work done. You can solve the other physical quantities also. Okay, in this way you can increase your capacity. So after doing that, you can get some knowledge from this part also. Okay, so thank you everyone. Thank you watching for my video. So keep watching my video and also subscribe my channel. Thank you everyone.